Hello students, welcome back to Future Foundation. Students, in last class of vectors, we did some questions based on cross product. Now in today's class, we will start plane. So let's start the class. First of all, write heading plane. In this, we will write first, let A and B be any 2 points having position vectors A vector and B vector respectively. Then the locus of the point which remains equidistant from points A and B always is the plane, or is the equation of plane. What I am saying, let us understand by looking at this figure. So A having position vector A vector and B having position vector B vector are any 2 points. Now point P is moving in such a way that it remains at equal distances from A and B. That is, if P is here, then this distance and this distance is equal. If P is here, then this distance and this distance are also equal. If P is here, because P is moving in space, so this distance and this distance are equal. So P will lie in the plane, or I can say P will lie in a plane. So I can say P will lie in a plane. So this is a plane in which P is lying, right? Or if A and B are these 2 points, then so this is the case. This is equal to this distance is equal to this, or this distance equal to this. So any point lying in the plane represents point P. Now, related to above definition, there are following remarks. Remark 1. It implies that, or the above definition implies that, the plane will also passes through A vector plus B vector by 2, as a vector plus b vector by 2 is the midpoint of the line joining A and B, right? This is the line joining A and B. Say this is the midpoint. So this point will also be contained by the plane. Remark 2. So we can say plane is the locus of a point which hold which holds a line joining two points two points such that it remains always perpendicular to the fixed line. And fixed line is line AB. So what I am saying in point 2, there will always be a line containing by the plane which is perpendicular to the fixed line AB. This line or this perpendicular line is called normal. It's called normal vector, represented by n vector, right? So this fixed line is called normal vector, right? Now what I'm saying in remark 2, let us understand by using this figure or by seeing this figure. As we have already seen that this plane will contain a midpoint of A and B. Say this point is C, right? And C vector is nothing but A vector plus B vector by 2, and R is R vector. So this CR will be contained by this plane, and perpendicular to this plane will be AB vector, and this AB vector is what? Normal vector n. So I can say this is n vector, right? So for equation of plane, I can write CR vector dot n vector is equal to 0, or R vector minus C vector dot n vector is equal to 0, right? So R dot n is equal to C dot n, and C vector dot n vector is a scalar quantity, so I can write this RHS as T. So R dot n is equal to T is equation of plane, right? So let us write a question. Find equation of plane which passes through 1, 2, 0 and perpendicular to 1, 2, 3, right? So this is C vector. C vector is nothing but 1, 2, 0. As we always require a plane, a point uh, through which a plane is passing, right? And a normal vector to determine the equation of a plane. So C vector is 1, 2, 0 and the normal vector is 1, 2, 3. So equation of plane is r dot n is equal to c dot n, right? So 1, 2, 0 dot 1, 2, 3. So if I put r as x, y, z, so x plus 2y plus 3z is equal to 1 plus 4 plus 0. So x plus 2y plus 3z is equal to 5. So if equation of plane is written in terms of x, y and z, then coefficient of x, y and z will represent normal vector and RHS will represent D. Okay, so if I write a question, find vector equation of 2x plus 3y minus z is equal to 2. So I need n vector and D. So n vector is nothing but 2, 3 minus 1 and D is, or R dot n is R dot n, which is D, is 2. So equation in terms of vector is R dot n, that is R dot 2, 3 minus 1 is equal to 2. This is vector equation, right? Okay, let us write a question. Find equation of the plane by using the given figure. Okay, and figure is this. Now we are given 2 points uh, making a line AB and which is perpendicular to the plane. Let's say in this plane point having r vector as its position vector. Now we all know if we want equation of plane, then we want a point which is lying in the plane and normal vector. So normal vector will become AB vector and point through which plane is passing will be the midpoint of AB, as it is or it is given that, say, this if this point is D, so ED is equal to PD. It is given in the question, right? D is the midpoint It is given in the question. It is the midpoint of AB, right? So D can be written as A vector plus B vector by 2, right? So equation of plane can be first PD vector dot EB vector is equal to 0, or R vector minus A vector plus B vector by 2, okay, dot B vector minus A vector is equal to 0. Also, equation of plane can be written as PD vector dot ED vector is equal to 0, or R vector minus A vector plus B vector by 2 dot A vector minus A vector plus B vector by 2 is equal to 0. Similarly, equation of plane can be R vector minus A vector plus B vector by 2 dot B vector minus A vector plus B vector by 2 is equal to 0, right? And the very first definition of equation of plane, which was the locus of a point which remains equidistant from A and B, is the equation of a plane, right? EP is equal to PP, or mod of R vector minus A vector is equal to R vector minus P vector. This is also equation of plane. Okay, now let us write one more question. Question is, find the following for the triangle given below. Triangle is A, B, C. A is 1, minus 1, 2. B is 2, 0, minus 1. C is 0, 2, 1. So what we need to find? What we have to find? First, area of triangle ABC. Second, cos of angle between PC vector and PA vector. Third, sine of angle between PC vector and PA vector. Fourth, vector of magnitude √6 and perpendicular to the plane of ABC. Fifth, find length of perpendicular from A to BC. Sixth, length of angle bisector. Seventh, circumradius of triangle ABC. And eighth, equation of plane ABC, right? So we need to find these 8 parts. Now let us draw again triangle ABC. This is A, 1 minus 1 2. This is B, 2 0 minus. This is C, 0 2 1. Okay. Now first part is area of triangle. ट्रायंगल का एरिया फाइंड करना है. मीन्स area of triangle is half mod of PC cross B, right? If we need to find area, so this will be half mod of PC cross PA, or AB cross AC, or CA cross CB. But in second and third, PC cross PA, PC and BA are involved. So we will use half mod PC cross BA. But if I expand this PC cross BA, then in this expansion sine theta will be appeared. So if sine theta will appear, so it's better that we should find sine PC cap BA first, and for sine we will find cos BC cap BA. So first of all we are finding second. So from E dot P is equal to EP cos theta, this cos of PC vector cap P vector can be written as PC vector dot PA vector on mod of PC vector to mod PA vector, right? So PC vector or mod of BC vector is nothing but magnitude of or length of PC. So using distance formula we can find PC. So root over 2 square plus 2 square plus 2 square. So this is root over 12, and root AB is, or BA is root over 1 plus 1 2 plus 3 square, that is 11. So root over 11, and AC is root over 1 plus 3 square plus 1, that is again this is root over 11. So PC is minus 2 comma 2 comma 2 dot PA is minus 1 minus 1 3 on root over 12 into root over 11. So this is 2 minus 2 plus 6 on root over 132. So 6 upon root over 132 cos of PC vector dot cap PA vector. So this is required answer for second. Now using this we can find third. Sine of PC vector cap PA vector is nothing but root over 1 minus 6 upon root over 132 whole square, which is 1 minus 36 upon 132, or root over 96 upon root 132, right? Now come to first. Delta of ABC is half mod of BC cross PA. Which is half BC PA sine theta, or sine of angle between PC vector and PA vector, right? So half root 12 root 11 into root over 96 upon root over 12 into root over 11, which is root over 132, right? So this will cancel out. So 1 by 2 into root over 96 can be written as 4 root 6. Okay. So this will become 2 root 6 square units. This is delta ABC, right? Now, 3 parts are completed. Come to fourth one. Fourth one is a vector perpendicular to the plane ABC. So for this, we need to find unit normal vector to the plane ABC, or I can say normal perpendicular to plane ABC can be PC vector cross BA vector. Oh, right? So n cap is nothing but PC vector cross BA vector on modulus of PC vector cross BA vector, because we are finding unit vector. So now PC vector cross BA vector is equal to I cap, J cap, K cap, BC. BC is what? BC is minus 2, 2, 2. Minus 2, 2, 2. And BA is minus 1, minus 1, 3. Minus 1, minus 1, 3. So this will be I cap times 6 plus 2 minus j cap times minus 6 plus 2 plus k cap times plus 2 plus 2. 8 I cap plus 4 j cap plus 4 k cap, right? Or 4 times 2 I cap plus j cap plus k cap. This is n vector. You can say n vector, but we need to find n cap. So n cap is 4 times 2 I cap plus j cap plus k cap upon mod of 4 times 2 I cap plus j cap plus k cap, right? 4 and 4 cancel out. So this will be 2i cap plus j cap plus k cap on root over 4 plus 1 plus 1, that is 6. So vector of magnitude root 6 and perpendicular to the plane ABC is root 6 n cap, which is root 6 n cap, or root 6 times 2i cap plus j cap plus k cap by root 6. So required vector is 2i cap plus j cap plus k cap. Okay. Now come to fifth one. Fifth one is length of perpendicular. So length of perpendicular and perpendicular to BC. If I didn't write perpendicular, so yeah, I have written perpendicular from A to BC. So perpendicular from A to BC is ABC. Perpendicular from A to BC. As triangle is isosceles, root 11, root 11, root 12. So triangle is isosceles. So perpendicular will be the median also. So as triangle is isosceles, so perpendicular will be median. Median also you can write. And A is 1 minus 1 2, B is 2 0 minus 1, C is 0 2 1. So D will be what? 1 1 0 using midpoint formula. So AD, length of perpendicular, will be root over 1 minus 1 0 plus 1 plus 1 2 2 square, that is 4, and 0 minus 2 square, that is again 4, which is root 8, which is 2 root 2. Now come to sixth one. Sixth one is length of angle bisector. Angle bisector of angle A, right? Length of angle bisector of angle A. So again, if triangle is isosceles, so angle bisector will be perpendicular drawn from A to BC, and which is median. So angle bisector is again median of BC, which is so length of angle bisector is 2 root 2. Now come to seventh, which is circumradius of triangle ABC. So using formula for circumradius, which is ABC upon 4 delta, where delta is triangle area of triangle ABC and ABC are the sides of triangle ABC. So EBC is root 11 root 11 root 12 upon 4 into 2 root 6, right? So this will be 11 upon 4 root 2. Now come to last part, which is equation of a plane ABC. Eighth one is equation of a plane ABC. So equation of plane is, we all know very well, equation of plane is r minus a dot n is equal to 0, where n is normal vector to the plane and a is a point containing by the plane, right? So E can be the any vertex of triangle ABC. So for the time being I am taking point A or vertex A. So equation of plane can be written as r vector minus 1 minus 1 2 dot n. N vector is nothing but vector perpendicular to the plane, which is this. Okay, so 2 1 1 dot 2 1 1 is equal to 0. So this is 2x plus y plus z is equal to 2 minus 1 plus 2, or 2x plus y plus z is equal to 3, which is required equation. So students, for today's class this was all about. Now let's meet in next class. Till then, bye bye, take care.